Welcome back. I was to read about typewriters, but let's do it later, tomorrow. Let's try finish this. Let's try finish this tree on my list. Then I need to do tomorrow Zilog Z80 and Z8000. I start to get tired.
Shockley Semiconductor Laboratory. Shockley Semiconductor Laboratory, later known as Shockley Transistor Corporation, was a pioneering semiconductor developer founded by William Shockley and funded by Beckman Instruments, Inc. in 1955. It was the first high-technology company in what came to be known as Silicon Valley to work on silicon-based semiconductor devices. In 1957, the 8 leading scientists resigned and became the core of what became Fairchild Semiconductor. Shockley Semiconductor never recovered from this departure, and was purchased by Clevite in 1960, then sold to ITT in 1968, and shortly after, officially closed. The building remained, but was repurposed as a retail store. By 2015, plans were made to demolish the site to develop a new building complex. By 2017, the site was redeveloped with new signage marking it as the real birthplace of Silicon Valley. Shockley's return to California, edit. William Shockley received his undergraduate degree from Caltech and moved east to complete his PhD at MIT with a focus on physics. He graduated in 1936 and immediately went to work at Bell Labs. Through the 1930s and 40s he worked on electron devices, and increasingly with semiconductor materials, pioneering the field of solid-state electronics. This led to the 1947 creation of the first transistor, in partnership with John Bardeen, Walter Brattain and others. Through the early 1950s, a series of events led to Shockley becoming increasingly upset with Bell's management, and especially what he saw as a slighting when Bell promoted Bardeen and Brattain's names ahead of his own on the transistor's patent. However, others that worked with him suggested the reason for these issues was Shockley's abrasive management style, and it was this reason that he was constantly passed over for promotion within the company. These issues came to a head in 1953 and he took a sabbatical and returned to Caltech as a visiting professor. Shockley struck up a friendship with Arnold Orville Beckman, who had invented the pH meter in 1934. Shockley had become convinced that the natural capabilities of silicon meant it would eventually replace germanium as the primary material for transistor construction. Texas Instruments had recently started production of silicon transistors, in 1954, and Shockley thought he could create a superior product. Beckman agreed to back Shockley's efforts in this area, under the umbrella of his company, Beckman Instruments. However, Shockley's mother was aging and often ill, and he decided to live closer to her house in Palo Alto. Shockley set about recruiting his first 4 PhD physicists, William W. Happ, who had previously worked on semiconductor devices at Raytheon, George Smoot Horsley and Leopoldo B. Valdes from Bell Labs, and Richard Victor Jones, a recent Berkeley graduate. The Shockley Semiconductor Laboratory opened for business in a small commercial lot in nearby Mountain View in 1956. Initially he tried to hire more of his former workers from Bell Labs, but they were reticent to leave the East Coast, then the center of most high-tech research. Instead, he assembled a team of young scientists and engineers, some from other parts of Bell Laboratories, and set about designing a new type of crystal growth system that could produce single-crystal silicon dual, at that time a difficult prospect given silicon's high melting point. Shockley diodes, edit. While work on the transistors continued, Shockley hit upon the idea of using a 4-layer device, transistors R3, that would have the novel quality of locking into the on or off state with no further control inputs. Similar circuits required several transistors, typically 3, so for large switching networks the new diodes would greatly reduce complexity. The 4-layer diode is now called the Shockley diode. Shockley became convinced that the new device would be just as important as the transistor, and kept the entire project secret, even within the company. This led to increasingly paranoid behavior. In one famed incident he was convinced that a secretary's cut finger was a plot to injure him and ordered lie detector tests on everyone in the company. This was combined with Shockley's vacillating management of the projects. Sometimes he felt that getting the basic transistors into immediate production was paramount, and would de-emphasize the Shockley diode project in order to make the perfect production system. This upset many of the employees, and mini rebellions became commonplace. Traitorous 8, edit. Main article, Traitorous 8. Eventually a group of the youngest employees, Julius Blank, Victor Greinick, Gene Huerny, Eugene Kleiner, Jay Last, Gordon Moore, Robert Noyce, and Sheldon Roberts went over Shockley's head to Arnold Beckman, demanding that Shockley be replaced. Beckman initially appeared to agree with their demands, but over time made a series of decisions that supported Shockley. Fed up, the group broke ranks and sought support from Fairchild Camera and Instrument, an Eastern U.S. company with considerable military contracts. In 1957, Fairchild Semiconductor was started with plans for making silicon transistors. Shockley called the young scientists the Traitorous 8 and said they would never be successful. The 8 later left Fairchild and started companies of their own. Over a period of 20 years, 65 different companies were started by first or second generation teams that traced their origins in Silicon Valley to Shockley Semiconductor. In 2014, TechCrunch revisited Don Hoefler's 1971 article, claiming 92 public companies of 130 descendant-listed firms were then worth over US $2.1 trillion. They also claimed over 2,000 companies could be traced back to Fairchild's 8 co-founders. Shockley never managed to make the 4-layer diode a commercial success, in spite of eventually working out the technical details and entering production in the 1960s. The introduction of integrated circuits allowed the multiple transistors needed to produce a switch to be placed on a single chip, thereby nullifying the parts count advantage of Shockley's design. However, the company did have a number of other successful projects, including the first strong theoretical study of solar cells, developing the seminal Shockley Querisor limit that places an upper limit of 30% efficiency on basic silicon solar cells. See also, edit. 1 Thyristor, a concept first proposed by William Shockley. References, edit.